Okay, so now after we have generated the hardware of our design, we can sort of now select an option that would basically allow us to launch the software development kit. So we can click it and we can sort of launch the software development kit or the SDK. Okay, now we are in the SDK or software development kit, and this is basically the software or computer side program that executes on the ARM Cortex core. So this is the software side of our accelerator, and this is the main function, and of course we have got this main argument. The mode to invoke this function is basically we have a CPU mode and we have an FPGA mode. So we can specify in command line arguments whether we want to run the code using the CPU mode or the FPGA mode. And there can also be a quiet mode where the software does not display important information. Otherwise, if it is not quiet, then it displays a lot of information while it is running on the FPGA. And of course, we can measure the per CNN time of the accelerator by using the function get time of day. So we generate the network basically, and when we generate the network configuration, of course we have this different network configuration that describes the whole network. Over here we can see that it is describing the net and the layers basically that are there. So all these layers have been defined, and they have been defined properly as far as this particular arrangement is concerned. So if we are using the FPGA accelerator, we initialize the FPGA accelerator, which basically initializes the driver. But when the driver is initialized, the Axilite interface is opened and the shared DRAM region is also opened. So now we allocate memory in the shared memory in DRAM for weights plus data by using this allocate DRAM memory net CPU function, and this function basically allocates the information, right, by using the particular sort of addresses that have been provided. And over here, if we are using the FPGA in this case, so the memory allocation would be such that we have the memory from the driver, the FPGA driver that is driving the circuit. Then of course we have this different weights and their initializations, and of course if we are using the FPGA block, we need to initialize the base address for the accelerator to use, and we must have the weights offset must be properly initialized, and input offset, the offset of the input that is provided to the network must be initialized as well. Then of course we load and copy the image into the shared memory area, and once the image has been copied, we start the processing of the layers, and we determine how many total layers are there, and we have this main loop that is processing each layer. So we fetch a particular layer from this thing, and of course after initialization we start the we first configure the FPGA layer by using the set layer config function, and then of course we start the FPGA accelerator, and we wait by the busy state protocol for the accelerator to finish, and we sleep for 100 microseconds just in anticipation. Afterwards we can have a time analysis. Basically if the status is to display everything and not the quiet mode of the accelerator, it basically would tell us everything, how much time the certain layer took. So once the layer is finished, we come out of this loop. We copy the results back from the shared DRAM by using the copy results from DRAM function, and this is basically the copy results from DRAM function, which uses the mcopy memory copy command to copy the data from the shared memory to the main program's memory. So after we have used the FPGA block, we release the FPGA block, and of course then we calculate the softmax by using the function calculate softmax. And calculate softmax function basically is used to calculate the softmax probabilities, and then of course the results are reported afterwards. And finally we have this test bench, which tells us whether our result was a success or our result was a failure. So this is the main execution of the software, and over here we have these helper functions in the down, which allocate and help out in different kinds of activities, and they have been called in the main calling program. So that's it for the software side introduction.